In this lesson, we are going to learn about subgrade underground drainage facilities. The extent of damage caused by groundwater to the subgrade varies with conditions. In mild cases, it causes seepage on the road surface and reduces the strength of the subgrade. In severe cases, it can lead to frost heave, frost boil, or slope collapse, and even the sliding of the entire subgrade along a tilted base. It may also cause devastating damage to subgrade engineering containing expansive soil. Therefore, by installing underground drainage facilities to divert and drain groundwater, it is necessary to adapt to local conditions and strive for excellence. Subgrade underground drainage facilities refer to structures that intercept, collect, and eliminate groundwater, or reduce the groundwater level to prevent damage to the subgrade. They are mainly divided into blind ditches, seepage trenches, and seepage wells. Now let's look at the first type, blind ditches. They are mainly used to drain springs and concentrate underground water flow, serving as underground channels that guide water flow without having seepage or catchment functions. We should pay attention to the following points when setting up blind ditches. 1. When there are isolated springs within the subgrade, and the spring water flows outward, and the road cannot be diverted, to guide the spring water beyond the slope of the fill or into the side ditch of the cut, a channel can be excavated between the spring and the outlet to construct a blind ditch. 2. Blind ditches or pipes can also be used to eliminate accumulated water for urban street sewers or storm drains, and for highway drainage designs at the curves of central reservation. 3. The construction cost of a blind ditch is generally higher than that of an open ditch. Once blocked, it is difficult to clear and may even require excavation and reconstruction. Therefore, an economic comparison with open ditch construction plans must be made during the design phase to choose the best option. 4. The longitudinal slope of the bottom of the blind ditch is recommended to be no less than 1%. If the outlet is a side ditch, the bottom of the blind ditch should be more than 20 centimeters above the highest water level of the side ditch to prevent backflow. 5. When using pipe drainage, the longitudinal slope of the pipe bottom is recommended to be no less than 0.5%, with the same outlet conditions as above. Next, let's learn about seepage trenches. Seepage trenches collect groundwater in the ditch through permeation and discharge the water to a designated location through the channel at the bottom of the ditch. Such underground drainage facilities are collectively known as seepage trenches. Their function is to lower the groundwater level or intercept groundwater. The types of seepage trenches include rock-fill seepage trenches, pipe seepage trenches, and tunnel seepage trenches. The cross-section of a rock-fill seepage trench is generally rectangular or trapezoidal. When fitting with finer particle size, medium sand, coarse sand, or gravel should be used as the filter layer. Its top usually needs a sealing layer, typically using double-layer inverted turf or other materials, and a clay waterproof layer with a thickness of no less than 0.5 meters is compacted on top of it. Pipe seepage trenches are suitable for areas with long underground water drainage and large flow. The pipe materials include ceramic, concrete, asbestos, cement, plastic, etc. The pipe walls have staggered drainage holes, with a spacing not greater than 20 centimeters. Tunnel seepage trenches are suitable for areas with a large flow of groundwater. The walls of the tunnel should be constructed with mortar rubble. The top should be covered with cover plates, leaving a gap of 20 millimeters between the plates, and the top of the cover plates should be laid with permeable geotextiles. The width of the seepage trench is determined by the depth of the ditch. Generally, when the depth is 2 meters, the width is 0.6 to 0.8 meters. When the depth is 3 to 4 meters, The width should be no less than 1 meter. The sealing layer of the seepage trench prevents soil particles from falling into the pores of the filled stones, thereby avoiding blockage of the seepage trench. And it also serves to prevent surface water from seeping into the ditch. The filter layer, on the other hand, is designed to collect water flow and to prevent soil particles in the aquifer from blocking the drainage layer. As you can see in these two images, the one on the left shows a plastic blind ditch, and the one on the right shows a PVC pipe. These two types of pipes are commonly used as drainage pipes in seepage trenches, known for their durability and pressure resistance. In this lesson, we have learned about underground drainage facilities. You need to distinguish these from surface drainage facilities of subgrades after class. Traditional construction methods should be the primary approach, combined with multifaceted innovation to promote the high-quality development of our country's freeways.